Greetings, fellow aviators. Today, we're going to talk about one of the most critical aspects of aviation. Approaches are the final phase of flight that bring us safely from the sky down to the ground, but not all approaches are created equal. Today, we're going to discuss the differences between ILS, Localiser, and RNP approaches, and where to find the approach minimums on the approach plates. First, we're going to talk about the ILS, or the Instrument and Landing System. An ILS is a ground-based navigation system that uses radio signals to guide the aircraft to the runway. It's a very precise and reliable approach that has been used for decades. Approach plates for ILS approaches show the minimums for decision height, DH, and runway visual range, or RVR, which are essential for safe landings. The minimums are located here on the bottom of the charts. This is the ILS Zulu or Localiser Zulu to runway 8 in Burbank. A DA or decision altitude is 1,075 feet MSL or mean sea level, or 348 feet AGL or above ground level. With the glide slope equipment inoperative, the minimums will jump to 1,160 feet MSL, or 433 feet AGL, as there's no vertical guidance. And folks, that brings us to our next approach, the Localiser. The Localiser approach, like the ILS, is a localizer, and it's a ground-based navigation system that uses radio signals to guide the aircraft toward the runway laterally. The main difference between the ILS and the Localiser approaches is that an ILS includes a glide slope component which helps the aircraft descend toward the runway at a safe angle. The ILS approach allows you to get very close to the runway with close minimums. A Localiser approach incorporates a dive and drive technique. The pilot actually has to use a combination of step-down altitudes to a higher minimum, as in this example for the 27 runway Localiser approach into San Diego. As you can see on the approach plate for this Localiser approach, it displays minimums for DH and MDA. The minimums for a non-precision approach, which is this type of approach, are typically expressed as minimum descent altitudes, MDA, and visibility minimums. The MDA is calculated by adding a buffer to the highest obstacle in surrounding area, or by using a predefined altitude established by the approach procedure. Some airlines will pad the MDA by adding 50 feet to give what we call a DDA, or derived decision altitude. Since MSL is a standard reference level used in aviation to measure altitude, MDA is expressed in feet MSL to ensure that all pilots have a common reference point for determining their altitude during the approach. By using a common reference level, pilots can communicate their altitude and ensure that they are flying at correct altitude during the approach. It's worth noting that in some cases, such as approaches to airports located at high altitudes, the MDA may be given in feet above ground level, or AGL, instead of MSL. This is because the surrounding terrain may be higher than the airport elevation, making MSL less useful as a reference for determining obstacle clearance. Finally, we have RNP, or Required Navigational Performance Approaches. RNP is a GPS-based navigation system that provides aircraft with more flexibility and precision when approaching the runway. Unlike the ILS and Localiser approaches, RNP approaches do not rely solely on ground-based navigation systems. Instead, they use advanced GPS technology to guide the aircraft to the runway. The RNP approach has two minimum RNP values, 0.30, 0.11, which refer to the level of accuracy required for the aircraft's position during the approach. In this case, the specific RNP value is 0.30 here in New Zealand. The choice of the approach depends on the aircraft's navigation capabilities and the pilot's training and experience. During an RNP approach, the aircraft must maintain a specific track to that runway within the required RNP value, using onboard navigational equipment. If the aircraft deviates from the required track, the pilot must execute a missed approach procedure or ask for a vector to rejoin the approach. RNP approaches allow aircraft to fly more precise and efficient approach paths, which can reduce the risk of collisions and increase the capacity of busy airports. Approach plates for RNP approaches display minimums for navigational performance, obstacle clearance, and missed approach procedures. In conclusion, Each approach has its strengths and weaknesses, and the choice of the approach ultimately depends on the specific conditions and requirements of the flight. As pilots, we must always remain vigilant and aware of the minimums for each approach, which can be found on the approach plates. So next time you're flying an approach, whether it's an ILS, Localiser, or the RNP, remember to keep a sharp eye on those minimums and fly safely.